Hi, everybody. Today we're going to talk about similar and congruent figures. Here I have some turtles. Aren't the turtles so cute? If you're looking at the first two turtles on the top, they are congruent, meaning they have the exact same size and shape. Now, when you look at them, they're not the same orientation, but that doesn't matter. What matters is that they're same size and shape. Then we say that they are congruent. We have a symbol in math for congruence, and it is this. It's the equal sign with a squiggly above it. That means congruent. Down below, we have like a mama turtle, baby turtle. They are similar, but they're not congruent. Similar meaning that if you look at them, they look the same, just one is bigger than the other. Our symbol for similar is this. Whoa, that's a bad. It's just the squiggly. Okay? Now on the next page I have some shapes. Let me get down there that are similar and congruent. What I want you to do is try and figure out which ones are similar, which ones are congruent, and use the lovely little shape that I showed you, or symbol that I showed you. Pause the video, copy them, and write it down. Okay, hopefully when you looked at these, you said, all right, well, these two are similar. These two are similar. These two are similar. These two are congruent. I hope you got that right. Hey, it almost looks like a face, doesn't it? Are you the? Okay, never mind. Anyway, that's what these are. They're similar, and congruent. Now, the thing that I want you to pay attention to, and you should write down what you think is important here. Similar and congruent figures, they both have the same shape. Notice that in the picture, they both have the same shape. The difference between similar figures and congruent figures is that congruent figures also have the same size. So, corresponding sides and corresponding angles, and you're like, ooh, what does that mean? That means the sides that are the same on the two shapes and the angles that are the same angles on the two shapes, they're corresponding to each other, they have the same measures. For angles, this is what we do, is we draw a little arc like this. And then we match it up with the corresponding one. And that means that those two angles are the same measure. And then we come down to here, now this is 90 degrees, we would probably do the box there. But here, I'm drawing two arcs like this. Those two arcs mean that those two angles are the same size, or same measure. And then over here, I would draw three angles. You come over here and draw three angles, meaning that these two angles here have the same measure as well. Okay? That exists. The length of the hypotenuse here, this long side of the triangle, is going to be exactly the same length as the corresponding side, or the hypotenuse of the other triangle, because they are congruent. Now, similar figures, that's not the case. The measures of corresponding angles in similar figures are the same, but the measures of the corresponding sides in similar figures are multiples of each other, or they're proportional to each other. So what does that mean exactly? All right, well, let me erase this little similar line there. And what I'm saying is that the angles here, this is a 90 degree, this is a 90 degree. All of the angles will be the same measure. But what happened is the sides were stretched, or they were shrunk. So if I had the length of this side, I said it was 15, and the length of this corresponding side, which was 5, and then I had the length of this side, 3, and I didn't know the corresponding side here. Well, these two shapes are proportional to each other. So what I'm saying is you could set up a proportion, you could solve for x, and find out what the length of that side is. Now, in order to do that, I think what we need to do first is go over a couple of proportion problems just to see how they're done. So let's go over a couple. Here are two proportion problems. Okay, I have a proportion, by the way, it's just a ratio equal to another ratio, in case you didn't know that. But I have here 3/8 is equal to x over 24, and I want to solve for x. Well, I'm going to show you the quick and easy way, and then I'm going to show you the algebraic way. If you're comfortable with equations, I want you to do the algebraic way, but it just kind of depends on what your prior background is. I know we haven't covered equations yet. So, the quick way, you take the two numbers, now we're multiplying diagonally, so you look diagonally, you take the two numbers that are diagonal to each other and you multiply them by each other. Then what you do is you divide by the one that's left over, and that's what x will be equal to. So, let me pull up my little calculator and show you. Okay, I have 3 times 24 divided by 8. Now, you can do all of this exactly without having to hit the equal sign, because order of operations, they'll just go from left to right. So I can do 3 times 24 divided by 8, enter, and I get 9. So, over here then, x is equal to 9. Now, the algebraic way, I'm going to erase my little lines here. Algebraically, I say multiply the number times the variable first. 8 times x would give you 8x. Then that would be equal to 3 times 24. 3 times 24 is 72. Then what I want to do is get the variable by itself, so I would divide both sides by 8. I want to get rid of that 8, and x is equal to 9. That's exactly what we said, right here. Okay? So you see that it works. Either way, whatever you're more comfortable with. So try to do the next one. Pause the video and do the next one. Okay, for this one, you would have, I'm going to do both ways. First, 7 times 25 divided by 5. And you would get y is equal to 35. Now, if I were to do it algebraically, I would have 5 times y, which is 5y, is equal to 7 times 25, which is 175. Divide both sides by 5 to get rid of that, get the variable by itself, and this is equal to 35. Either way, they both work. Now let's try and do it with some similar figures, because that's where it gets a little interesting. Here I have some similar figures. What you need to do when you set these things up, you need to set up the ratios. And the ratios are going to be one side over the other side. So I would have 4 over 7.5. Then I'm going to set that equal to another ratio. The key thing here is this. What I did is I took this one over the other one. So I have to go to its corresponding side and make sure that I set it up the exact same way. Whoa, hold on, what did I do there? There. I have to set it up the exact same way. So here I put the short side over the long side. Over here, I have to put the short side over the long side. So 3.2 over x. In other words, I took the corresponding sides and I put them in the, if I put the short side in the numerator on one side of the ratio, and I put the short side in the numerator of the other one. They're corresponding to each other. Then what I would do is I would multiply diagonally. I would do 3.2 times 7.5 divided by the one that's left over. And x would be equal to 6. So here this is equal to 6. Now what I want you to do is draw the next two shapes. And I want you to solve for the missing sides there. Be careful because we have y, z, and x over here that are missing. So you actually have 3 things that you want to solve for. So pause the video and solve for those. Pause it. Okay, I'm going to start with, now it doesn't matter what order you start with, but what does matter is how you set up your ratios. I'm going to start solving for x, so that way I have this one figure done. What I'm going to do is take this side over this side. Now hopefully you realize that if you set this up somehow differently than what I did, you'll see that you still get the same answer as long as you put corresponding sides in their appropriate location. So here I have 10. I did this side here. Its corresponding side is there. So I'll put that up in the numerator. I have x down here. The corresponding side is this, the 5. And then I would multiply diagonally. I had 5 times 10 divided by 4. And x is equal to 12.5. Again, you could have solved it a different way, but as long as you followed your corresponding sides, it should have worked. So now what we're going to do is solve for y. This time what I'm going to do is I'll use this number over this number. So I'll go 8 over 10 is equal to y, that's the corresponding one with 8, over 4, which is corresponding with 10. Do 8 times 4 divided by 10, and y is equal to 3.2. I'm going to erase these. And then my last one, z. I'm going to do this. I'm going to go 10 over 15. Again, it doesn't matter. 10 over 15 is equal to, what's corresponding with 10? 4. So that goes up in the top. Corresponding with 15 is z. That would do 4 times 15 divided by 10, and z is equal to 6. That is all. See you later, my friends. You'll have a good day.